All right, guys, so we're going to be starting a new unit. It's the final unit of the year. And in this lesson, you're not going to learn anything new, but I think what you're going to see are some unique ways to think about things that you probably already knew. So, what we're going to talk about are circles. We've been talking a lot about circles, and we're going to specifically talk about the circumference of a circle and the area of a circle. And in order to do that, we're going to identify a very important feature of circles that you may or may not have known existed. So I want you to sketch a circle in this space, and I want you to do your very best to measure the radius of this circle. If you have a physical piece of paper in front of you, you can actually measure that distance, and then you could cut out a tiny little piece of paper that is exactly that distance. And what I want you to do is see how many times you can take that little piece of paper that is the same length as your radius and fit it along the outside edge of the circle. So lay that radius down, there's 1. Lay that radius down, there's 2. Now obviously I'm estimating here because I don't have a physical piece of paper in front of me, but you do. 4 radii. 5 radii, 6 radii, and then there's a little bit left over. So if you did this exercise like me, you should find that you also have basically the same number of radii that fit around the edge of your circle. And it doesn't make any difference how big your circle is either. So even if you have a teeny tiny little circle, well, the radius is also proportionately teeny tiny, and that tiny little radius is also going to fit 1, 2, 3, 4, 5, 6, and a little bit of change times around the outside edge of the circle. And that little bit of change is about 0.283185307.2 of a radius. So it's a little bit more than a quarter of a radius, a little less than 3/10 of a radius. And you may have seen a number that's sort of like that before. So what we're going to say here is that the circumference of a circle is equal to about 6.283 radii. This is probably not the formula that you've learned in the past. But the formula for circumference that you've learned in the past, which is circumference equals 2 pi r, actually is the same as this formula, because that 6.283 is just 2 times pi. That's what that is. Remember, pi is 3.1415926, goes on and on and on and on and on. This number is just twice that. So what we're seeing here is that the number of times a radius fits around the outside edge of the circle is twice pi. That's what we're seeing. And another way to write this formula, so circumference is 2 pi r, yes, but it's also true that pi times the radius is going to be equal to half the circumference. Or in other words, if you take that radius and lay it down pi times, or 3.1415926, on and on and on and on, you will get half of a circumference of the circle. That's where this formula comes from. And obviously another way to write this, because we know that 2r is diameter, you may have also seen this written pi times diameter. That's the same thing. So that little formula, a formula that you've seen before, but what we're seeing is that this is always true of every circle, and the circumference of a circle is equal to 2 pi radii. Okay. So that's circumference. Now I want you to sketch another circle in the space below. And I'm going to go ahead and put in a little circle here. Okay. Now what I want you to do is to imagine that you're starting from the center of this circle and you're drawing thousands and thousands of little rings, perfectly circular rings, from the center of the circle to the outside edge. So in the very center, you're going to have just the tiniest little ring. And then after that, you're going to have a slightly larger ring. And after that one, you'll have a ring that's a little bit larger than that one. And then you'll have another ring outside of that one. Now imagine there is actually zero space between these rings. My drawings here aren't perfect, but imagine that these are perfectly circular and there's no space at all between each ring, and we continue this pattern. So I'm just going to pause the video here and fast forward this process. Okay, so it's not perfect, but I've filled in the whole circle with perfect rings. We're going to pretend that they are perfect. Now what I want you to do is to imagine that you could take any one of those rings and you could pull it off of the page and stretch it out so that it's a vertical line. So I'm going to do that with the longest ring, this one around the outside. I'm going to pull it off the page and I'm going to stretch it out and dangle it. So that's what that is this outer ring, the last ring that was created. Pulled it off the page, stretched it out, super long. Okay, then I'm going to take the next ring before that one, and I'm going to lay it right next to it. Now that's going to have to be a little bit shorter, right? Because that ring didn't have to go as far because it was closer to the center of the circle. And we'll just keep going and grabbing one ring at a time and laying them down. Now we're visualizing what this is going to look like, right? Obviously it's not going to be perfect, but we can imagine that if we just grab every single ring, and it's all in theory, assuming that our lines are perfect and our circle is perfect, and that there are so many of these that there are no gaps from one ring to the next. Ultimately, what we would have, if we did this perfectly, is we would have a triangle. And it would be a right triangle. So the question is, what do we know about this triangle? Well, the first thing we know is that the area of this triangle has to be equal to the area of this circle, because all of the rings that made up the interior of this circle have now been used to create this triangle. So these two areas have to be the same. And I know how to calculate the area of a triangle. The area of a triangle is 1/2 base times height. So what's the base? Well, what is that distance coming from? If you look at where these rings came from, what this is it's the innermost ring, and then the ring after that, and the ring after that, and the ring after that. So that distance is this distance. It's the radius of the circle. So the base here is the radius. And what about the height? Well, the height is just the length of that outermost ring, which is really just the circumference of the circle. So the height of this triangle is the circumference of the circle. So I can replace height with circumference. And if we play around with this formula a little bit further, well, circumference is 2 pi r. So that means that the area, the area of the circle and also the triangle is equal to 1/2 of 2, which is just 1. Those two things are going to cancel each other out, pi, and the radius times itself. So that's a little formula for the area of the circle. Now, I think you already probably knew that formula. You've probably never seen where that formula comes from. This is just one example of an explanation of the area of a circle. So we'll get a little bit of practice using these here. What you need to do is do all of the practice problems on the back of this notes sheet. I'll provide you with the answers to one from each section here, but you should do them all. And then I will post my notes key tomorrow, so you'll be able to see if you did them all correctly. So you're looking for the area of each circle below for level 1. I think maybe I'll do this last example here. So remember, area of a circle is pi r squared. Well, in this case, my radius is actually 1/2 of 35, because 35 is the diameter, so my radius is 1/2 of that. If I'm being asked to round this to the nearest 10th, then I'm going to end up with 962.1 kilometers. Level 2, determine the circumference of each circle. Let's go ahead and do this one here. So since circumference is equal to 2 pi r or pi d, I'm going to try to use pi d here because I've been given the diameter. So that's pi times 58 if we're rounding to the nearest tenth. And that's going to be approximately 182.2 yards. Well, I should say above, the area of the circle is 962.1 kilometers squared, because area would be a squared measurement, whereas this 182.2 yards is just a one-dimensional measurement, so that's just yards, not yards squared or something like that. And level 3. Let's take on this one here. Not that it's the most challenging of all of them, but you should try to do them all. So determine the measure of the diameter of a circle with a circumference of 18.2 inches. Well, if circumference is pi d, and the circumference turns out to be 18.2, then the diameter is just going to be 18.2 divided by pi, which is about 5.79 inches. So again, I'd encourage you to do all these for practice. You do have homework related to this as well, and we will go over a couple of these tomorrow at the beginning of class.